Hello, my amazing students. This is Mrs. A, and I love math. And we are here today talking about Lesson 13, adding and subtracting fractions and mixed numbers. Now you can see I got a new light, so I've got to watch out how I use it. I'm going to have to hold the board this way. Okay, adding and subtracting fractions and mixed numbers. And we're on Lesson 13. And under the new concept in our book, it gives us a little word problem because we're talking about adding fractions and mixed numbers. And it says leftover from the pizza party were 3/8 of a ham and pineapple pizza and 2/8 of a vegetarian pizza. What fraction of a whole pizza was left? And if Mario eats 2 of the slices of the ham and pineapple pizza, what fraction of the ham and pineapple pizza will be left? Well, if you remember correctly, we had 3/8 of a ham and pineapple and 2/8 of a vegetarian pizza. When we have the same denominators, that means we have the same size pizza, and it's very easy to add them together. So when we have the same denominator, all we have to do is add up the numerators. 3 plus 2 is 5. We have 5/8 of a whole pizza left, okay? And then down here we had 3/8 of the pineapple and ham pizza, and then someone came along and ate 2 of the pieces, so that's 2/8 of the pizza. And then how much do we have left? 3 minus 2, since we have the same denominator, we have 1/8 of the pineapple and ham pizza left. So when we're adding and subtracting like denominators, it's very, very simple. All we have to do is add the numerators together and simplify. So here we have 3/4 and 3/4. So we're going to add those together. And when we do, since the fourths are the same on the bottom, we have 3 plus 3 is 6/4. But now 6/4 is an improper fraction. So we're going to make it into a mixed number. 6 divided by 4 is 1 with 2 left over. 2/4 is what's left, but we're going to simplify to 1/2. So 1 and 1/2 is the same thing as 6/4. Now down here we have 3/5, take away 3/5. So hopefully you know that's 0. Since we have fifths and fifths in the denominator, we just take away the numerator, which is 0/5, which is indeed 0. Okay, so at the top of your page 86, they have some bar charts or number line walks here. So if I were going to do a number line walk on this one here, okay, so we have 3/4, and I'm going to do a number line. We'll start with 0 because we're adding only positive numbers. So here's 1 and here's 2, okay? So we're going to add 3/4, which is right there, and another. So basically, remember, we divide in half and then divide in fourths, so that's 3/4 right here. And then another 3/4. So 1, 2, 3/4. Do you see how I end at 1.5? Okay, we could divide this into fourths too. So 1, 2, 3, 1, 2, 3. We end at the half mark in between 1 and 2. So that's 1.5. Okay, so on this problem now, we're starting to add fractions that do not have a common denominator. So in order to do that, we're going to put them over a common denominator by adjusting both denominators. Sometimes you only have to adjust one denominator, and sometimes you have to adjust both. So we're going to think, what is the smallest number that both 3 and 4 go into? Well, hopefully you know that that is 12. 3 and 4 both go into 12, and we're going to rewrite both fractions over 12. Okay, now let's think about it. If I want to get from 3 to 12, I have to multiply by 4. So I'm going to multiply 2/3 by 1. But 4 over 4 is 1. And I'm choosing the right form of 1 to get my fraction to 8/12. Okay, and if I simplify 8/12, don't I get 2/3? I do. Okay, so then we're going to come over here and we're going to change fourths to twelfths. And again, I'm going to always multiply by 1, but I get to choose which form of 1 I will use. So 4 times 3 is 12. So I'm going to multiply by 3 over 3, which is 1. 3 times 3 is 9. 4 times 3 is 12. So now I have changed my problem into like denominators of 12. So now that they have like denominators, then I only have to add the numerators and then simplify. So we're going to add 8 plus 9 and get 17 over the common denominator of 12. Now, 17/12 is improper because the numerator is larger than the denominator. So I'm going to divide 17 by 12 goes 1 time. So then I take that 12 away from the 17 and I have 5 left. So 1 and 5/12 is the solution. Okay, so now let's do another one of those. Okay, we have 3/4 minus 1/6, 2 different denominators. So we're going to turn them into the same denominator, and the least common denominator between 4 and 6 is 12 again. Okay, so we're going to multiply by 1 and multiply by 1 in 2 different forms to get 12 on the denominator. So 12 is my goal, to get 2 fractions with 12 on the denominator that are equivalent to the originals. So 4 times what is 12? It's 3. So we're going to put a 3 over a 3, and that's going to be 9/12. Minus, I keep the sign, 6 goes into 12 2 times. So I want this one to be 2 over 2. And 1 times 2 is 2. 6 times 2 is 12. 9, since they have the same denominator, my difference will also be 12ths. 9 minus 2 is 7, and there's nothing I can do to simplify 7/12. That is already the answer in its best form. Okay, so now we move into mixed numbers. So we have 3 1/2 plus 1 3/4. Now, sometimes it's easier if you put this in a column form. It really is okay to do it either way, but let's go ahead and write this in column form. So I'm going to write 1 3/4 here, and we're going to do this in column form, but I'm going to show you a little adjustment that I'm going to make. Since I have to come up with like denominators, the denominator between 2 and 4, that is the least common denominator, is 4. So isn't this one already written in the right form? So I'm just going to rewrite it. Okay, this one, however, 1/2 is the same as 2/4. So I'm just going to write this 3 2/4. And now I have the same denominators and I'm ready to add them. So I have 2/4 plus 3/4 is 5/4. And then 3 plus 1 is 4. Now, that is the right answer in the wrong form because 5/4 is improper. I'm going to need to put it in its proper form. 5/4 all by itself is 1 1/4 because 5 divided by 4 is 1 whole with 1/4 left over. So instead of 4 5/4, we're going to take 4 plus 1 1/4, okay, because 5/4 is the same as 1 1/4. And 4 plus 1, these are the whole numbers. 4 plus 1 is 5 1/4. So our answer is going to be 5 1/4. It's a little bit cramped over there, but 5 1/4 is the answer. Okay, this is example 3. It says we have 3 1/2 take away 1 3/4. So we need to get a common denominator. So now on this one, I think I'll leave it in its horizontal form. Okay, we'll just try it that way. So I need this to be fourths. So I know that 1/2 is the same as 2/4. So I'll write 3 2/4 minus 1 3/4. Now we know if these were done in a column format, we would want to subtract our fractions first, and we want to do that this way too. But 2/4 minus 3/4, uh-oh, something's not working. So what we're going to do is we're going to take 1 away from the 3 and make that 2, and then take that 1, and it is 4/4. Okay, so we're going to add, put a little minus there, we're going to add a 4/4 to the 2/4. So we end up with 2 6/4. 2 plus 4, and there's a 4 on the bottom, and then minus 1 3/4. So now we have 6/4 take away 3/4 is 3/4. So we'll have 3/4, and then 2 take away 1 is 1, and the answer is 1 3/4. Okay, so here are our rules for adding and subtracting fractions and mixed numbers. Okay, write the fractions with common denominators. Okay, so even on mixed numbers, we have fraction parts in the mixed number, and that's what they're talking about. Okay, add or subtract with regrouping, and then simplify if you can. Okay, now that's what we just did. We regrouped. We had 3 2/4, but 2/4 was not enough to take away 3/4. So we changed the 3 to 2, and then this 4/4 was added to the 2/4 to make 6/4. Okay, when we regroup like that, we do have an improper fraction, but then when we perform the subtraction, it is no longer improper, is it? Okay, so that was a good example of that one. So here is example 4. Now this is in word problem form, but they're talking about a 2x4, and a 2x4 is a board that is, we typically think of it as 2 inches by 4 inches thick. Okay, but they're telling us that actually, in this problem at least, a 2x4 was really 1.5 inches by 3.5 inches. So if we stacked the ends of 2x4s on top of each other, what would be this new dimension here? Okay, so we have high, it's going to be 1.5 plus 1.5. So let's do 1 1/2 plus 1 1/2. We're adding them together. And of course, won't this dimension here, I guess we could call it the length of the bottom, okay, it's still going to be 3.5, because even though it's taller, it's still 3.5 wide. Okay, so what would this be? 1/2 plus 1/2. 1/2 plus 1/2 is 1 whole, isn't it? Okay, so 1/2 plus 1/2 is 1 whole. I'm going to add the 1 whole here, and we took care of those. 1 plus 1 plus 1 is 3. So we're going to have 3 inches tall and 3.5 inches wide. Okay, so we're on example 5 of our lesson. This is a nice short lesson. Okay, let me read it to you. The carpenter cut 15 1/2 inches from a 2x4 that was 92 5/8 inches long. How long was the resulting 2x4? Or what is left is the resulting, isn't it? So here we go. We have 15 1/2 taken from or cut off of a 92 5/8 long board. So now we're going to say 92 5/8 minus 15 1/2. Okay, so now we're going to subtract, but we need a common denominator. 2, thankfully, goes into 8 evenly. So we need to multiply the 1/2 by 4/4. Okay, so 1 times 4 is 4, 2 times 4 is 8. Can you see how 4/8 is the same thing as 1/2? It is, isn't it? So now we're going to look at the fraction parts. 5/8 take away 4/8. We have enough, don't we? 5/8 take away 4/8 is 1/8. And then 92 take away 15. We're going to have to rename here, aren't we? So we've got 2 take away 5. Does not work. So we're going to come over here and make this an 8 and a 12. 12 take away 5 is 7. 8 take away 1 is 7. And we get 77 1/8, which is correct. Now, make sure you pull out your packets. This A is starting on your packets for you. This is your practice set. This is A. So on A, we have 4/9 plus 5/9. Remember, we started the section with the like denominators, the easy stuff. So 4 plus 5 is 9. We get 9/9. But remember, the last step of our process is simplify if we can. And 9/9 is 1. So the answer is 1. 9/9 would be improper, wouldn't it? Okay, so for B, we have 2/3. Take away 2/3. Hopefully you know that that's 0, because anytime we have a number take away the same number, it is 0. Okay, but anytime we have the same denominator, we just subtract the numerators, which would give us 0/3, which is 0. Okay, I hope you're copying these down. This is practice problem C. 1/8 plus 1/4 is going to be 4 goes into 8 evenly, so let's let that be the least common denominator, because it is. So we're going to multiply by 2/2, which is 1, and we're going to have 1/8 plus 2/8 equals 3/8. That's pretty simple, isn't it? All right, here's D. We have 5/6 minus 1/2, but 1/2, 2 goes into 6 evenly. So let's let our form of 1 be 3/3, and we'll have 5/6 take away 3/6. Can you see that? That's the same as 1/2. 3/6 equals 2/6. But 2/6 needs to be simplified. Divide by 2 on the bottom and 2 on the top, and we're going to get 1/3. So the problem's answer is 1/3. Example E, we have 4/5 plus 1/2 is going to give us, we don't have a common denominator between them, do we? So let's go to 10. We're going to go to 10 and 10, and we're going to think about, what do I need to multiply 5 by to get to 10? And that's 2. So we're going to multiply by 2/2. 4 times 2 is 8. 5 times 2 is 10. And 2 times 5 is 10. So we're going to multiply the top and the bottom by 5 and get 5/10. Then when we add them, since we have common denominator, we get 13/10. But 13/10 is improper. So we're going to divide, how many times does 10 go into 13? 1 whole time with 3 left over. So 1, and 3/10 is the answer. Okay, so here on example or practice problem F, we have 1/3, take away 1/4. So we're thinking, what's the least common denominator between 3 and 4? And we know it's 12. Okay, so we're trying to get to 12 and 12 on the denominator. So we think of, what do I need to multiply 3 by to get to 12? And that's 4. So I'm going to multiply by 4 on the top and 4 on the bottom, multiplying by 1. 4 over 4 is 1. And we're going to get 4/12 minus, now here, I'm going to give myself a little bit more room. 4 times 3 is 12. So we're going to multiply by 3 over 3, and that's going to give us 3/12. And 4/12 take away 3/12 is 1/12. All right, so G is here. All right, so G is 3 1/3 plus 2 1/2. So our fractions are the problem, right? So we're going to rewrite them with 6's on the bottom because 2 and 3 both go into 6. So that'll be 3, and I need to multiply this one by 2 over 2 to get 6 on the bottom. So that's going to be 2/6 plus 2, and I'm going to multiply this one by 3 over 3 to get a 6 on the bottom, and I'll get 3/6. Okay, so now we're going to add. So we've got to do the fractions first. 2/6 plus 3/6 is 5/6, and 3 plus 2 is 5, and 5 and 5/6 is the answer. Practice number H. Okay, letter H, not number, right? So 6 and 5/6 take away 2 1/3. Okay, well 3 goes into 6, so we really don't need to change the 6 fraction. Let's just change this to a 6. So we'll say 6 and 5/6 can stay like it is, minus 2, and I'm going to multiply by 2 over 2 to get 2/6. And now we can do the math. So 5/6 take away 2/6 is 3/6. 6 take away 2 is 4. But 3/6 is not in its most simplified form. What if I divide by 3 and divide by 3? I'm going to get 4 1/2. Okay, so here we have I, and we have 3 1/2 plus 1 2/3. Now we have to get a common denominator between 2 and 3, and that would be 6. So we're going to have 3 and something over 6 plus 1 and something over 6. Now to get 1/2 to something over 6, 2 times 3 is 6. So we're just going to multiply by 3 over 3. 1 times 3 is 3, and 2 times 3 is 6. So they're the same thing, right? We're just naming them different. And then 3 goes into 6 2 times. So I'm going to multiply by 2 over 2. 4 on the top, 6 on the bottom, and we're ready to add. 3/6 plus 4/6 is 7/6. So we have an improper fraction we're going to have to simplify in a minute, or rename. 3 plus 1 is 4, but we know that 7/6, 7 divided by 6 is 1 1/6. So we're going to say 4 plus 1 1/6 is, the final answer is 4 plus 1 is 5. 5 1/6 is the complete answer for the problem. I ran out of room, had to write it somewhere else. Okay, J, we have 7 1/3 minus 1 1/2. So again, 6 is the common denominator. 7 1/3 is 2, 6. So I multiply 3 by 2 and 1 by 2. I'm multiplying by 2 over 2. and getting 2/6. Now, I'm trying to get to 6 in the denominator, so when I multiply by 3 over 3 and get 3/6. So minus 1 and 3/6. Okay, so now we have a problem. Here we have 2/6, take away 3/6. That doesn't work. So we need a bigger number here. So we're going to take 1 away from the 7, make that 6. We're going to add here. Let me make a little bit more room. We'll move our minus weight in here. We're going to add a 6 over 6. We always choose the denominator here. So now this is 6 and 8/6 minus 1 and 3/6. Now, when I finish, 8/6 minus 3/6 is 5/6. And we'll just write that right there, 5/6. And 6 minus 1 is 5. So the answer is 5 and 5/6. So then on practice K, we have to revisit practice H. So it says on K, did you need to rename a whole number to subtract? Why or why not? Okay, and the answer is no. Okay, we already did this problem. It should be already on your paper, so I'm not going to do it again. But the answer is no, we did not need to rename a whole number because 5/6 is greater than 1/3. So when you got the common denominator, remember that was 2/6 and 5 take away 2 was no problem. Therefore, we did not have to rename the whole number. Okay, so we're on our last two practices. Let's read them. Nelson wants to replace a piece of molding across the top of a door. Now, it has a picture in your book on page 90 of this problem, okay? The door frame is 32 and 1/4 inches wide and is trimmed with molding on each side that is 1 and 5/8 inches wide. How long does the molding across the top need to be? Now, if you look at the picture, the molding across the top needs to overlap the trim on the side, the molding on the side. So here's the picture. Okay, can you see that picture right there? Okay, you see how the molding across the top has to overlap the molding on the sides. So what they're really asking is how long is that molding on the top at its longest point? So we've got 32 and 1/4, and we're needing to add the 1 and 5/8 that is on both sides. So can you see why this is a problem for this lesson? We have fractions of different denominators and we're adding them all together. Okay, so the easiest way to do this, since these are both in 8ths already, and this one is in 4ths, we can change 4ths to 8ths just by multiplying 2 over 2 on the fraction. So we're going to multiply by 2 over 2, and this 1/4 is going to become 2/8. Easy as that. So now we're going to add all of our fractions together. We have 2/8 plus 5/8 plus 5/8. So 10/8 plus 2/8 is 12/8. So let's write down 12/8, which is improper. We're going to have to adjust that. And then 32 plus 1 is 34. Okay, so now the 12/8 we need to fix. 12 divided by 8 is 1 whole, which is going to be added to the 34 to make 35, isn't it? Okay, and then after we take away the 1, which is the one we just added there, that was 8/8. So 12/8 take away 8/8 is 4/8. And 4/8 is correct, but not simplified. 4/8 is the same as 1/2. So the answer to practice L is 35 and 1/2. Okay, so M is our last practice problem. And let's read it. It says, at the top of a bulletin board, if the top of a bulletin board is 74 3/4 inches above the floor and the bottom is 38.5 inches above the floor, then what is the vertical measurement of the bulletin board? Now, the vertical measurement would be the height of the bulletin board, wouldn't it? Okay, so it says that the top of the bulletin board was 74.75 inches, and the bottom of the bulletin board was at 38.5 inches above the floor. So again, if you look at the picture in your book, it makes it a little bit easier to understand. And they're showing you the two measures, and to find the height of the board, don't we need to subtract those two fractions from each other? Okay, which is exactly what we're going to do. So here I have 74.75, take away 38.5. So we're going to subtract, and I need common denominators again, don't I? So I'm going to change the 1/2 to 2/4. All I did was multiply by 2 over 2. And now 3/4 take away 2/4 is 1/4. And 74 take away 38. 4 take away 8. We're going to have to make this a 6. Rename those. 14 take away 8 is 6. 6 take away 3 is 3. 36.25 inches tall or high. Okay, now I'm starting to help you with your written practice, your homework. I'm starting to do it for you. So I'm going to always do the first 5 problems. Here we go. This is number 1. Okay, number 1 says, there were 65,000 people at the stadium. 80% of the people had been to the stadium previously. How many of the people at the stadium had been there previously? So don't we just need to find 80% of 65,000? Okay, now remember that 80% is 80 over 100, right? 80% of 65,000 is 80% times 65,000. Okay, so now can I take these 2 zeros and these 2 zeros and cancel them away? I can't. So now I'm only going to have to multiply 80 times 650 because these are gone. Now, to do that easily without having to worry about a lot of zeros, and since I have very limited space on my board, can I just multiply 65 times 8 and then tack on 2 zeros? I can. I can take that 0 off and that 0 off and do the math and then put those 2 zeros right back on. So I'm going to multiply 65 times 8 because I have a very small board. And 5 times 8 is 40. And 6 times 8 is 48 plus 4 is 52. And then I'm going to tack on the 2 zeros. So 5, 2, 0 with 2 more zeros added. There were 52,000 people that had been in the stadium before. Okay, so here we have problem number 2. And it says a dime is about 1 millimeter thick. How many dimes are in a stack 1 centimeter high? Okay, so now what we have to do is know what a millimeter is and how it relates to a centimeter, right? So if a dime is 1 millimeter, there would be, a millimeter is 1/1000th of a meter, okay? And then a centimeter is 1/100th of a meter, okay? So millimeters, there's going to be 10 millimeters in every centimeter. Okay, 10 millimeters in every centimeter. So if each millimeter is a dime and we're looking for how many in a stack, 1 centimeter high, the answer is 10 dimes because there are 10 millimeters in a centimeter. Okay, number 3 on your homework says, flying at an average speed of 525 miles per hour, How far can a passenger fly in 2 hours, 3 hours, and in 4 hours? Well, this is simple multiplication, isn't it? Because 525 is what is flown in 1 hour. So 2 hours would be double that, wouldn't it? So if we double 525, we're going to have 1,050. In 3 hours, we're going to have triple that, which would be 1,575. And in 4 hours, we're going to have 4 times that. And remember, there's 4 quarters in a dollar. So 4 times 5 is 20, plus one more from all of these is going to be 2,100. And we did that without even having to multiply, because they used easy numbers and you could pretty much do it in your head. We are on our last 2 practice real problems. Then you get to go off and do your homework, okay? So number 4 says a whole pizza was cut into 8ths. So how many 8ths are in a pizza? 8 eighths, right? If Hector eats 3/8 of the pizza and Rita eats 1/4 of the pizza, then what fraction of the pizza remains? Okay, so we have 3/8 and 1/4 that are being eaten. And when we change the 1/4, we need a common denominator. So let's multiply by 2 over 2, and we have 3/8 plus 2/8. So altogether, they ate 5/8. But that wasn't the question, was it? They said how many pieces were left over, or what fraction. It says what fraction of the pizza remains. So we have 8/8 altogether. Take away 5/8, which was eaten. 8 take away 5 is 3. So the answer is 3/8 of the pizza was eaten. So you had basically 2 equations in there that you had to use. It said to find the equations, but first we had to add these 2 pieces together. And then second, we had to take the whole pizza, which was 8/8, take away the 5/8 to get the 3/8. Okay, so you had 2 equations that you should use. All right, so then the last problem is problem 5 in your book. And it says the ceiling fan company sold 7,400 fans this year and 6,900 fans last year. How many more fans did they sell this year compared to last year? So this is a comparison, but you're going to do it by subtracting, aren't you? You're going to put 7,400 minus 6,900. That's your equation. And then we're going to subtract 0, 0. We're going to need to come over here and rename 6 and 14 take away 9 is 5. 6 take away 6 is 0. So they sold 500 more fans this year than last year. Now, we have done all of your practice problems together, every example in the book, and the first 5 problems of your homework. So I hope that you are off to a good start and will do your homework well. This is Mrs. A, and may God bless your day.